Now, what are the consequences of being on the rotating planet and the Coriolis effect? The most important one, and something that is part of everything we see on Earth, ocean circulation, winds, pressures, etc., is the so-called geostrophic balance, geostrophic flow, geostrophic currents, and so on. How to think about it? Let's just say we have high pressure and low pressure arranged this way. So we're going from 612 millibars, and there are various ways pressure is measured: hectopascal, millibar, and other units that I won't get into. So let's say we are looking at flow aloft so that we don't have to worry about friction, because geostrophic balance assumes that there is no friction, and there are anything that modifies geostrophic balance, like creating change in time or acceleration, tend to be called ageostrophic flows when they are close to geostrophy but deviated by a little bit. Okay, so let's not get too far. So 612 millibar, 608, 604, 600. You would expect that the pressure gradient force will drive a flow from high pressure to low pressure. So if you release a parcel, or let's say a balloon, then it should start to move in that direction, wind in this case. But as soon as anything moves, Coriolis is going to act on it. So pressure gradient force is in that direction, wind starts off that direction, Coriolis begins to pull it towards the right. So you can see that now wind, as it's accelerating because of the pressure gradient force, is going to be deflected more to the right, accelerate more to the right, and then eventually it'll become balanced between Coriolis effect and the pressure gradient force. This is the special case where geostrophic balance has been accomplished, so that the wind is now driven by a balance between pressure gradient force and Coriolis effect, no acceleration, so equilibrium, steady flow, and no friction, so that you can balance just Coriolis and pressure gradient, and wind can flow without pressure. What is amazing here, if you stare at it for a minute, you will see that now the wind, instead of going from high pressure to low pressure or towards low pressure, it is now going along constant pressure lines, or isobars. How amazing is that? So these are, flow is totally parallel to the isobar, and you can see this clearly in the upper level charts. If you watch weather forecasts, especially in mid latitudes, this is at 40 north or so over the US, you can see that there are many places where flow is completely along constant pressure lines, and there is a certain direction of circulation around high pressure and low pressure, high pressure and low pressure, depending on which hemisphere you are in, of course, because Coriolis flips sign across the hemisphere. So here it is in July. We will see that in July there is a high pressure here, and in January the high pressure has moved further south and has shrunk, and low pressure has expanded. So we will add these kind of dynamic details as we go along, but here just notice again this, in case you hadn't already noticed this, just see how amazing it is that flow is basically along isobars, constant pressure lines, instead of going from high pressure to low pressure. So high pressure is here, the pressure is lower around, or a low pressure is here and pressure is higher here. So instead of flow coming in, flow is going around the constant pressure lines. This is the amazing thing about geostrophic balance or geostrophic flow. We can now also extend our Coriolis knowledge to understand cyclonic and anticyclonic flow in the northern hemisphere. You can flip these directions and also do cyclones and anticyclones in the southern hemisphere. So let's again say that there is low pressure in the middle and there is high pressure all around. Many of these figures I have taken from a book called Illustrated Guide to Weather and Climate, and another book called The Atmosphere. So I think I cite it somewhere, but sorry about that. So flow again begins to go from high pressure towards the low pressure center. Coriolis begins to act, so you can see that pressure gradient force remains towards the from the high pressure towards the low pressure in every direction, and Coriolis keeps creating a balance such that pressure gradient force and Coriolis effect are balanced, and the flow ends up being in a counterclockwise direction or anti-clockwise direction around a low pressure system. It's called cyclone because cyclonic flow, hurricane cyclones do go counterclockwise in the northern hemisphere, and you can see here we are going from 1004 millibars to 1012 millibars, so low pressure to high pressure. So it's called cyclone because in Greek, cyclos or some such word means rotating in the same direction as the planet. Remember the planet, if you think this is North Pole and you are looking down, actually this would be North Pole high pressure. Then Earth is rotating from, let's say, west to east, so you can think of this as west to east flow or counterclockwise flow or cyclonic flow. So this is how you should be able to derive basic concepts of cyclone and anticyclone just using your knowledge of Coriolis and tilt to the right in the northern hemisphere. So by the same token, if you have high pressure in the middle and low pressure everywhere, the starting point can be here where the air wants to go from, or water wants to go from high pressure towards lower pressure. Coriolis begins to pull it towards the right, and you end up with a clockwise flow or an anticyclonic flow. So this is the consequence of the rotational effects or Coriolis effect. So immediately we can jump to see that if we want to look for atmospheric circulation, we have high pressure still at cold polar latitudes, we have low pressure still at equatorial low latitude regions where sun's energy is coming in and less energy is being lost to space than being received, so there's the energy surplus, warm temperatures, and air is getting warmer and rising, and evaporation is happening and the air is carrying water vapor with it. So as air rises, again hits the tropopause, and remember pressure decreases with height, so air expands, cools, water condenses, we end up with these clouds and rainfall. So you end up with this cell here, converging air without worrying about the asymmetries about the equator, which we will add later on. So just assume again a rotating planet with no land, just water, for example. So convergence into the rising air is going to be tilted, so air wants to come from higher pressure towards lower pressure. Coriolis is pushing to the right, so you end up with these northeasterly trade winds. From the south, air wants to go from lower pressure towards higher pressure towards lower pressure, so you end up with tilt to the left, so you have southeast trades, and these are called doldrums because the air, when it comes together in the middle, it goes to zero, so they are weak winds for sailors. If you want to sail, no winds is not a good situation, so those are called doldrums. But you see that we have complicated the situation now. Air is not going to be able to go directly from the poles to the equator because of these rotational effect. Air that is flowing out from the high pressure at the poles is again going to experience a Coriolis and be tilted to the right. So instead of going south, it's going southwest. So these are the polar easterlies, and there is a scale which is determined where the easterlies don't go any further south, and you have created another situation where the air above is going to be also deflected to the right, so you are going to have sinking at some point, and that's going to be the end of this cell. So the air, rising air, is not being filled in by air coming all the way from the poles. Coriolis is going to change all that, so the air is only coming from the subtropics, so from both directions, and you have convergence, rising air, flowing poleward and sinking and coming back. So you have created these closed cells called the Hadley cells. But as the air moves poleward in the upper atmosphere, remember that we are moving at 1600 kilometers per hour here, and we are only moving at 1400 kilometers per hour here, which means this air is going to acquire an eastward speed. So that is going to create the strong eastward jet here, which we call the subtropical jet stream. Okay, I'll come back and add these other details in the next podcast, but I hope this allows you to take the Coriolis effect, which is a simple concept, extend it to geostrophic balance, extend it to cyclones and anticyclones, and now combine it with the convection, rising air hitting the tropopause and diverging and sinking somewhere because of Coriolis as well, and create Hadley cells. Okay, we have just added 1 plus 1 plus 1 plus 1. Not very complicated, but just go through, make sure you understand. Okay, so we will see the other complications in the next podcast, and there are details we'll keep adding, but this is a good way to learn dynamics if without any maths, just the physics, and it's also good to understand this much even if you want to then go off into biology, chemistry, social science, engineering solutions, whatever else. Okay.